Hey everyone, quick question. Who here loves spending their Friday nights configuring VPCs and writing Terraform? Yeah, most of them don't. So picture this, it's a Friday evening or any business days. You just finished building this awesome app, spent 2 weeks on it, works perfectly on your laptop. You push it to GitHub and think, great, now I just need to deploy it. Fast forward 3 hours, you're on your fifth tutorial about VPC, learning about subnet configuration and all the other things, and also wondering what even is a subnet, like what even is a NAT gateway. Now that we have AI, you eventually turn to ChatGPT or Claude, and sure, they can help. But there's gotta be a better way, right? I'm Raj, and over the past few weeks, I've been building Sirpi, just another AI product to add to the growing list out there. But here's what makes this one different: AI agents that can actually collaborate with each other to handle the entire workflow. Let me show you what happens when an AI agent talks. So this is the landing page for the Sirpi. So for this demo, I'm going to use a simple task management app that I built called Taskflow. Nothing fancy, just a single shot prompt to Claude, which gave me a demo that needs deploying. Let's connect it. This is the template that we provide, and watch what happens when I click generate. Now the magic is 4 AA agents powered by Amazon Bedrock just started working. But here's what makes this different. They're not just actually running in parallel, they're actually having a conversation. So agent 1, which is the context analyzer, is examining my code right now, and it's found it's a Next.js application which is built with React, Tailwind, CSS, and runs on port 3000. And we have other two agents, which is basically a Docker file generator and a Terraform file generator. So every time these agents analyzes the code base and updates the context in agent code memory, it's like a shared brain where agents leave notes for each other, and the other agents reads from it and basically builds on top of it. 30 seconds later, we have our complete infrastructure code ready, which includes Dockerfile and all the different configuration we need for the Terraform. And that includes all the Terraform variables, Terraform backend data, and also the main.tf. Once you're good to go, we can create a pull request, and it will actually create a pull request in our GitHub repo, and then you can review the code and then you can merge it. So these are the files that got generated. I'm just gonna go ahead and merge it. So once you merge it, you come and refresh here, we can go for the deployment, just the next stage. Now to deploy this, most platforms would ask for my AWS access keys, but I'm not doing that. So instead, what we are doing is Sirpi would ask you to create a CloudFormation stack in your AWS account, which basically creates AWS IAM role and also other permissions that is required for creating all different apps. That includes DynamoDB table and also an S3 bucket, which tracks the state. Let's see how it works. So once I click Start Setup, I will be redirected to a URL which already has a CloudFormation template hosted in my S3 account. We can see the created stack here. If you want, we can view the template and then read through it, but I'm just gonna go and create the stack. This might take a minute or two in order to complete, and this essentially creates all the different kinds of resources which we can see here. So once the create is complete, the user has to basically copy this role URL, role ARN, and then go back to the Sirpi and then give it here. Perfect. Now Sirpi can deploy using temporary credentials. Want to revoke access later? Just go to the CloudFormation stack and then delete it. No credentials leak, no vendor login, you stay in control. Let's build these things. So this build is actually building a Docker image and then pushing it to ECR. The logs you are seeing is actually coming from the E2B sandbox, which is a completely isolated environment where the build is happening. Because Sirpi works with multiple GitHub repositories, including the ones that might have questionable code, the sandbox ensures that even malicious code can't touch Sirpi's infrastructure. Alright, cool. Now the build is done, we can proceed to do the Terraform plan before deploying it. This Terraform plan, we can see what we are creating. This shows VPC, load balancers, ECS cluster, everything we need. So once you confirm and verify, we can proceed to basically apply the Terraform plan and create the resources. Alright, now the Terraform has told us it has to create 26 resources, 0 to change, 0 to destroy because we haven't deployed it yet. Now let's go ahead and deploy the infrastructure. So Terraform is provisioning real infrastructure right now, creating VPC, load balancers, ECS cluster, etc. All this is happening in my actual AWS account. So at the moment, we don't have a cluster created yet. Let's wait for it and then see what happens. Alright, and we're live. So it says apply complete, resource created 26, 0 change, 0 added, 0 destroyed. And here you go, we have the ALB DNS name, which is basically where our application has been deployed. If you come here, this would have been populated with the new application URL. We can visit this and then basically have our app run here. But this means the cluster is being created right now, and then we can check for the status here. So you see there is still one pending resource that has to be created. We have one active. Yeah, here we go. So this is our application which is got live directly from GitHub to live application in minutes. If you ever need to destroy the infrastructure, all you have to do is click this button and it will basically delete all the resources that are being created by the Terraform. And then you can go ahead and then delete your CloudFormation stack, which means there is no dangling resources. There is no extra cost that's going to come to you if you ever need to move out of the Sirpi application. Well, that's Sirpi, AI agents collaborating through Amazon Bedrock Agent Core Memory to automate the entire DevOps workflow. Thanks for watching.